Okay, good afternoon. Thanks for coming to the graph-based business intelligence talk. My actual agenda is to get you to happy hour as soon as possible. The bartender's already out there, and yeah, I am too, so we're gonna just go. Briefly, we're gonna hit three main areas. We're gonna talk a little bit about why we should use graph for business analytics. I'm assuming most people are generally on board with graph, but we'll talk specifically about them in sort of that context for a bit. And then we'll spend a bunch of time talking about the challenges inherent in using existing BI tools with a graph source. And then we'll kind of go ahead and we'll look a little bit into the future and talk about how to do graph-based BI and kind of moving beyond the current state. So who am I? I'm the co-founder and CTO of FactGem. We've built an application based on graph technology. Yeah, and I've done stuff. Yeah. So why graph for business analytics? Again, it's a graph conference, so we're all, in some degree, graph people. But I think the question becomes, is there a place for using graph in essentially more common everyday business analytics as opposed to very specialized use cases? And of course, I think the answer is absolutely. Not for everything, but for an awful lot of things. And one of the main reasons is businesses these days, they run on relationships. Right? It's not like things were 30 years ago where you could really just kind of look through a narrow lens to understand a piece of the business. Now you've got to put it all together. All the businesses live in a context. You have to relate your customers to other customers, to their accounts. You've got to stick everything together to understand the context of what's happening in order to be competitive. And this is especially true when you're trying to compete with some of the really big online giants, the Amazons, the Airbnbs, because one of the ways that they maintain their competitive advantage is by really leveraging all of the data they have in context to gain that competitive advantage. But so, why do the relationships matter? Again, it's all about context. So let's look at a few specific examples of what I mean by that. So fraud detection, great example for graph databases and for business intelligence, right? Fraud detection doesn't happen in a vacuum either. People that are doing fraud detection, they need to see reports. They need to understand when something gets flagged as suspicious. They need to understand the context of all of that. They need to run numbers for their boss to show them how much fraud has happened and what the financial impact of that is and so forth. Very traditional business analytics types of reporting and data manipulation. And of course, graph, again, is perfect for fraud. Using graph to detect weakly connected clusters are great for looking at account takeover, synthetic fraud, things like that. A whole bunch of work obviously been published on various graph algorithms for fraud detection. So it presents an excellent opportunity, again, for putting some sort of BI tool on top of that. Supply chain. Again, a great candidate for a BI tool type of visualization, data manipulation, and supply chain, again, by definition almost, is very much a graph problem, right? It's how do you take your supply chain from a reactive situation to a proactive situation so that you can get in front of a supply side or demand side disruption. And again, supply chain is very, very complicated. Lots of moving parts, lots of things connected, many degrees of separation, and being able to visualize that again, run the reporting on it, absolutely crucial. And it's something that graph, again, obviously is very, very good at because of you need to analyze all of those complex relationships in the supply chain. So customer 360, often used in retail, right? So this is understanding how customers are related to each other, related to your products, what kind of behavior they're engaged in. So you might be doing basket analytics, right? Understanding when someone goes to the store, if they buy a pen? Do they buy paper as well? A classic retail analytic. And we'll talk about that in detail in a use case a little bit later on. But brand performance, customer engagement, again, lots of BI being used in this space, but Graph is particularly useful here because you really do need to understand, again, the relationships from customer, often 10, 15 degrees of separation through product, doing recommendations, and so forth. So having talked a little bit about the need to use Graph in the context of very traditional business intelligence type environments, let's spend some time talking about the challenges that exist currently. In order to do that, I think it's important we step back a little bit and we talk a bit about the history of BI. So where did it come from? How do we get to where we are today? Actually, the term first popped up in a paper published by a researcher out of IBM in 1958, where it was described as an automatic system developed to disseminate information to various sections of any industrial, scientific, or government organization. So that was a long time ago, right? We've been really predating common database usage as we tend to think about today. So the idea, though, of BI has been around a long, long time now. We fast forward a little bit, in the early 90s is kind of when BI really hit its heyday. Companies like Cognos and Business Objects really pioneered what we think of today when we think of BI tools, going from that old green and white sort of paper report that we had closer to 1958 to these nice line charts and bar charts and really fancy visualizations and almost infographic looking dashboards that we get now through a lot of the big tool vendors. And again, so really the outgrowth of modern BI. But we have to realize that as this BI was developing, again, primarily in the 80s and 90s, really it was based off of relational tables. It was really designed to let people stop having to spend so much time writing SQL queries and then figuring out a way to visualize and report on that, and just make that whole process faster and easier. So all of the roots are really stored in relational databases. And even today, with new BI tools coming out, many of them will tout as one of their key, if not the key, differentiator, they're really advanced SQL generation. There's companies out there right now using AI, as a matter of fact, to generate wildly complex SQL that is supposed to really outperform like anything anyone is likely to sit down and write on their own. And that's cool, and that's good, but it's all tabular. And as we're all here probably very much familiar with, the sort of the big dirty secret of the relational database world is they're not so good at relationships. Get out 3 joins beyond, performance really, really suffers. And the schemas can be very, very complicated, right? And that disconnects the business often from the data. And we'll come back and talk about that in a little bit as well. But I think it's interesting that the relational database, they're so bad at actual relationships, a lot of organizations will turn them off. Has anyone here ever been on a project where you joined the project and you've gone in and you look at the ERD or you got a dive in database and you notice that there's no foreign keys? Yeah, right? It's totally freaking terrifying. You step up, you're like, I worked on a project for the government many years ago, and I went on and I said, I don't understand. I must be doing this wrong. I don't see the relationships. Like, oh, we took them out. They were slowing things down. I'm like, wow, that's just really terrifying. This is at a major law enforcement agency, as a matter of fact. But you can, right? You can. You don't have to put them in there because they're not really real in the relational database. They're kind of this little story we tell ourselves to make ourselves feel good about all these joins and relationships we're going to do. So it's a problem. And as we mentioned, again, because of the way they grew up, current BI tools, all of them, are locked into the concept of tables. All of the core concepts present in any of these BI tools, whether it's from MicroStrategy or Tableau or Looker or any of the new ones that are coming up, like every single day Domo, it's all tabular. And because of that, there's difficulty scaling to graph. For the most part, they want a single source of data. They want to be able to look at one database and get the information from there. Now, it's not entirely true. There are now tools in some databases, rather in some BI tools, such as Tableau's Blender, which are designed to let you grab information from multiple different databases and bring it together in Tableau. But that's challenging. It's a great idea. It's a cool tool. But still, what you're doing is taking data from a bunch of different databases and ultimately bringing it back into a single database. It might be virtual, it might be in memory. It's still coming down to a single source. And it's in tables, of course. And with some of those tools, you're essentially doing data federation. So they may not take the information from the multiple databases and pull it into a new database. They might literally be doing data federation on the fly. So querying, when you issue a query through the BI tool, they might query data source 1, data source 2, data source 3. And of course, the challenge there is manifold. One, you're always as slow as your slowest source. If one of those databases is not performing well, the whole thing's going to be held up. Doing joins, as we know, in a single database are hard. Doing joins across databases is a nightmare. And you've just added additional points of failure. What if one of those goes down? So having to worry about keeping one database up, you've got to keep up 2 or 3 or 4. So it's not really a solution. Now, of course, we know that on the good side, this is why you want to use graphs. Right? Graphs are designed for relationships. They're designed to let us do those essentially joins across many degrees of separation. Depending upon the database technology you're using, you can do hundreds or thousands or more of relationship hops per second. So this is really, really important. Right? This is why we want to do graph. And of course, if in your particular context, for whatever reason, you really are not worried about relationships, maybe you just have a whole bunch of numbers and things and you need to crunch them and do some math, sure, that's probably not the right technology here for you. But of course, now you can use all this really nice analytics, right? We can do cluster connect, we can look at clustering, we can look at similarity, we can look at shortest path, page rank, all of these algorithms that are built to let us understand the relationships in the data. So this is, of course, again, just back to why we want to power it with graph. So why don't we just connect directly then? Take our modern BI tool and plug it into the graph. That would seem to be the logical answer. Well, there's one really major hurdle. As you're probably all aware, there is no standard graph query language. There are many popular ones. There's Cypher, there's Tinkerpop, and then there's a whole bunch of other ones that are less popular and often very vendor specific, but there is no standard. Good news, there is now a blessed W3C working group, the Property Graph Schema Working Group that has been in place for about 6 months now. It has been charged with W3C to create this group, and it's being has wide support. It's being led by vendors such as Neo4j and Oracle, as well as others, and they're plugging away very hard. But the reality is there won't be a V1 of this for at least 3 to 4 years. This is a complex topic. It's going to take a while. And until that comes out, there is no way a major BI vendor like a Tableau or a MicroStrategy or Microsoft even is going to spend their money building a BI tool that talks to your graph database when they know in 3 to 4 years that language is going to change. Not going to happen. 3 or 4 years, I think we can pretty much bank on it happening. It'll take a little time to do, obviously. But in the meantime, we've got this gap. We've got a whole bunch of time without a tool that we can directly connect. So how do we get there? We still need to do BI. We really want to use our graph database to do all those interesting things we've been discussing. So how do we get there? Well, the good news is with most technology problems, with enough code, enough effort, we can usually get there. So let's look at some options. 2 major options, of course, exist. One, you can just expose the data live. Most BI tools have some kind of an API for allowing you to expose your data source. Very often, one of the most accessible ones is going to be through web services. So Tableau, for example, lets you create a web services data source. And essentially, you write a little bit of an HTML page with some JavaScript. And you're telling Tableau, hey, you go to this endpoint, and I'll give you data. And the data I'm going to give you has this shape. So you're going to explain to Tableau, I'm going to give you 4 columns. And this is the name of the column. And for every column, this is the data type you can expect. Pretty easy to do. Most connectors have something similar to that. So that's one way to do it. Or you can export the data. We're going to talk about the challenges with both of these in a second. Exporting, of course, presents one major challenge. If you're working with a customer or a client, you've now already gone on this journey where you've convinced them, or maybe it's even internally, that what you really need to do to solve your business problem is have a graph database. And that was probably not easy. It's easier now than it was 4 or 5 years ago, but it still is probably not easy. Well, now you get to go and tell them, you know, we solved the problem in graph, and I showed you some raw data. I know you want that BI. All we have to do is add a relational database back and export the data from one to the other. That is not a conversation you want to have. I've had that. We'll talk about that. You don't want to do that. Trust me. It's not good. Really not a pleasant conversation. So let's talk about why even exposing the live data or exporting it is still problematic. Here's a very simple graph result. So let's say you're doing a query and you're in a retail scenario and you're looking at customers, and a customer makes a transaction. Transactions have line items on them, right? So think about a receipt. Every line of the receipt is a line item, and those line items are associated with products. So here a customer's gone in, they've bought 2 of one thing and 1 of another. It's very simple to see in a graph. It's very, very concise. We know exactly what's going on. So that's great. Well, what if we want to take this graph, we want to make a table now? Because our BI tools, remember, they only speak tables. Well, so we build up our table, and the challenge, as you can see here, is we have a massive amount of duplication because we have to essentially denormalize our nice graph structure into this table. And in this case, 66% of the data is duplicated. Right? For every line, I've got to tell you I'm still talking about the same customer, and I'm still talking about that same transaction, and maybe the same line item. It's a lot of data. For this example, sure, it's a couple lines, who cares? But that was a really trivial example. You're not just pulling back 4 things, you're probably pulling back 25,000 things or so, maybe more, with more properties. This is now a problem. How much of a problem? Let's do a little case study. So one of our major customers was a Fortune 200 retail company. They ran an entire chain of stores, roughly 1,600 stores on the graph, covering everything from associates and inventory and, of course, customers and sales and products and customer loyalty, all of that in the graph. It was a pretty big graph. It was over 4 billion nodes, over 24 billion properties, and over 20 billion relationships. It was about 5 terabytes on disk. So it was a good chunk of graph. Real data, yeah. This is 2 years basically worth of data for a major retail. Nope, this is very much not a toy. So it was going really well. We've been in business with them for a couple of years, and we were doing lots of great analytics that they just couldn't have done before. So for example, basket analysis, I mentioned a little bit earlier. Of course they did basket analysis before the graph. Challenge was to do basket analysis before the graph, they had to go to several different data sources, pull the data, bring them into Excel, run a bunch of analytics. Took them an average of about 6 days to do basket analysis for one store. That's sort of a top-level SKU. When I say top-level, meaning so this particular case, they were selling some clothing. They could tell you, for example, if you bought a hat, you bought gloves with it. But they couldn't go another level deeper and tell you what size gloves or what color gloves. That was just too much data. So they had a very thin slice of it. And that's pretty typical, it turns out, in the industry. By going to Graph, none of that time go down from 6 days to about a second and a half. You could go down a whole other level of detail. So we showed them, for example, for this particular product, if you just look in at the top level again, you see that I buy stockings, for example, with this skirt very often. That's good to know. Now when I say, actually I want to break it down further, I want to put the size in there as well. What you saw is that if I bought the medium set of stockings, the thing that was most often purchased with it is the large. Well, that's interesting. Why is that? Well, it turns out there's a sizing problem. People are going in, they don't know what size they are. They're buying them both, and then they're coming back and they're returning one later. That's the problem. They had no idea. So we were doing lots of these kinds of analytics, doing lots of reporting on it. Customer segmentation, market penetration, product comparison for bringing in new products to market, doing test products, year-over-year comparisons of sales, and segments, and so on. It was great. What wasn't great is they wanted to self-serve, right? We had basically been producing a lot of nice reports for them every week, but they wanted to self-serve. They wanted to do BI. They were a big BI shop. They wanted to have a dashboard where they, of course, can go in, and they can look at the data and pivot and so on. It's a reasonable thing to want to ask. So we teamed up with a major BI vendor that they had an enterprise license for, and we worked with their top consultants and said, OK, well, the kind of pivoting you want to do and all the data you want to see, we're going to need a pretty beefy box. We need a terabyte of memory. Wow, I didn't think they'd even get that. I didn't have a terabyte of memory across all 3 of the boxes I had for my graph database combined. I'm like, OK, but they got it. They gave them the terabyte of memory. I'm like, OK, that's cool. Wish I could have asked for that earlier. So we did a test with them, and we made the data available live. On a small scale, that worked great. It was super fast. And it was really easy to do. And I said, OK, but what about when we go from 30,000 things to 4 billion things? You go, yeah, that's not going to work live, because that we kind of hold that in memory, and this is not going to work. We really needed you to put it in a relational database. I was like, oh, man. So back to that conversation I said you don't want to have. I made them have it. But we had to be there, of course. But they got the relational database, because it turns out like everyone's happy to give you a relational database. Like, sure, have one, have 2. So they got it. So we exported to a relational database. And we worked with their consultants on what should the schema look like to produce these dashboards that they wanted, because they're obviously the experts. It's their product. Yeah, well, we failed hard. Really, really hard. On an average, it'd be about 30 minutes to load a dashboard. Now, clearly, no one that wasn't on the development team ever did that, because why would you do that to yourself? But that's about how long it took to load. If you preloaded it even, the moment you pivoted on something, yeah, go to a meeting, come back, it's 30 minutes. Why? That's what we've been talking about. The size of the data explodes when you go to tables. So we obviously weren't bringing the entire database over. That would have been crazy. We weren't bringing all 5 terabytes over. But you've got roughly that 66% of expansion, whatever you had in the graph, coming back over. That's a lot of stuff. And they, of course, wanted to do the analytics that they were used to seeing coming out of the graph. They want to understand those 15 degrees of separation away effects. Well, to do that in the relational, you can't join it, so you've got to essentially materialize all of it, more data, spread it out. It's just too much. It never, ever launched. Multiple months with the BI tools consultants before the project got shot. It's not good. So it's kind of a downer note there. Where does that leave us, though? Where does that leave us? How do we get to a graph-based BI? You can still get there. We just have to work a bit harder, unfortunately. And spoiler alert, there's still a lot of work that has to be done in this area. So what are some things you can do? Well, first off, you can do some pre-processing on your graph, right? Now this is kind of a conundrum, because you're trading off flexibility for performance. What I mean by that is a lot of the reason people want to go to BI and they want to self-serve is they want to just have the data there and be able to pivot on it in a whole bunch of different ways, kind of in an ad hoc fashion, and explore the data, which is great. I mean, I think everybody wants to do that to some level. Well, if I'm going to pre-process a lot of that, I've got to know ahead of time. I've got to know ahead of time what those questions you're going to ask are so I can do those analytics back in the graph where I can do them at speed, materialize the results back in the graph, and then I can export them to the relational database. That's a trade-off. And it may not be one that you or your customer is willing to make. But it does let you do the heavy lifting in the graph and potentially get to a solution that can now be managed in a relational-based BI tool. If you're going to pre-process, obviously you can do your own thing. You can write your own algorithms or whatever and do that. There are, of course, a couple of good options out there already. The Apache Spark project. Anybody familiar with Spark at all? Oh yeah, good, a bunch of people. So Spark, big open source platform for doing essentially streaming data analytics and massive data analytics over really large amounts of data. So Graphx is a fairly new addition to that. It is essentially an add-on, an API, for allowing you to deal with graph data structures and graph databases and do parallel computation in Spark. So you can spin up a big cluster of Apache Spark, put Graphx on it, and do a whole bunch of algorithms, things really, really fast. Ships with a bunch of things out of the box, like PageRank, connectedness, triangle counts, a handful of others. And of course, you can always write your own and still take advantage of the massive parallel processing. Similar project is called Graphx. Graphx is very similar. Also works with Apache Spark. It's based on Spark data frames instead of RDDs, kind of a low-level detail. Has a few more out-of-the-box algorithms than Spark, or Graphx rather does, like label propagation, shortest path, a couple others. Again, though, you can always write your own. It's a little bit of a newer project, lacks some of the more robust features like clustering and so on that you might get with, you would get with Graphx. And again, the challenge, of course, of pre-processing, even using Spark, you've got to remember that I've got to take the data out of my graph, I got to move it somewhere else, it's going to churn, and then I got to get it back and then give it to my BI tool. That's probably not going to be instant, right? Even just the data transfer alone is going to take some time, so now you've got to think about how do I operationalize this, right? Can I do this overnight? When's a good time to get this done? So still challenges there, but definitely doable. Other options, a bunch of your data science tools, more and more now, are actually building connectors or have connectors to talk directly to your graph database. Now, of course, back to not having a standard query language, your mileage is going to vary. Depending on what database you use, there may or may not be a connector. The reason you're getting the data science tools is, again, there's just the cost of building a connector here is far less than the cost of building a completely new BI tool with non-tabular concepts. The data science tools are used to just dealing with data. It's pretty easy to create the connector. For sure, there are connectors for R, so if you're using RStudio. The connectors for Jupyter Notebook, again, depending upon your database. I know both of them have connectors for for Neo4j, but essentially for anything that is running on a Bolt protocol. Visualization options, of course, are going to be somewhat limited, right? Depending upon what comes with your data science tool, but you typically have something. So it's not not really a bad choice. Yeah, and of course you can build your own. There was actually a really, really good talk this afternoon. I hope I don't butcher her last name. Lynn Pasonic, I believe, was her last name, of Expero. Did a really nice talk on designing a user interface for graph data. Really, really nice. I recommend you reach out and get a copy of that. But yeah, you can build your own, certainly. Things to think about, of course, in doing that. People still want what they think of as traditional BI visualizations. They're going to want bar charts. They're going to want pie charts. They're going to want line graphs. They're going to want all of those sort of standard things. But of course, you need to give them the value that is coming out of the graph still. So you need to package up those graph algorithms in an interesting way so you can see that. You're not necessarily going to want to show them that sort of network graph view that we all kind of immediately think about when we think of graph visualization. In a business case, really very small number of people want to or need to see that. They like it, it looks cool, and they might spend a good portion of their day just kind of playing with it, but that's not really what we want them to be doing. So you can do it. We're in the process of actually doing this at a product level, but it's certainly not done. And of course, you have to deal, it's a major effort, right? You have to deal with all of the challenges that would come with any kind of really large data solution, right? How long does it take to run the query? How can I make that faster? Because people aren't going to wait for it to, I'll sit there and wait for my dashboard to reload after 20 minutes if it's a really big query I've got to run. So you still have those challenges. Because unfortunately, we're probably about 3 to 4 years out from the big vendors actually stepping in and doing this. But again, I think the good news is you can get there. You just kind of got to be aware of the challenges. And at small scale, yes, you can connect a traditional BI tool to the graph. Just be really, really wary of scale right up in front. You've kind of got to very much anticipate how large is this going to get, how flexible do they need it to be, and take a good hard look over at can you really get it to scale that large for your set, and if not, potentially look at one of these other options. And with that, I will take questions if you have some. The bar's right up there. That's the first answer. Yeah. No, so we actually have built a product natively on top of Graph, a couple of different graph databases. We'll have a booth out there tomorrow. But basically what we do is we enable you to do all the modeling necessary for the graph, do all the data integration, pulling in different sources to load it into your graph, manage your scheduling. So if you I want to run a query every day at 3 in the morning, take the results of that query, send it to an R process, take the result from the R process, save it to a file and email it to 4 people, all of that kind of stuff, integrate external data. So we let you do all of that without having to write any code. It's a no-code, drag and drop solution for graph management integration. All right, party time. Everybody go. Thank you.